Hi, thank you for joining me for part 2 of the Celestron 130 EQ video. In part 1 we went through the assembly process and we looked at some of the pitfalls and things to watch out for. In part 2 we're going to cover some footage of the moon with various lens sizes. We're going to look at the Starfinder and see the best way to calibrate it, and we're going to look at some other hints and tips that you might want to consider for your telescope. You can get many accessories and upgrades for your telescope. You can get extra lenses with bigger zooms, and you can get adapters to hold cameras onto the eyepiece, allowing you to take photographs and videos of the things you see in the sky. You can also get something called a Barlow Lens. This allows you to use your current lenses but magnify them much further. We're going to cover those first in this feature. Here we have the Barlow Lens in situ, so you can see what it does to the actual telescope and how it fits. This is a 5x Barlow, and it does make the eyepiece extend a little further. I'll remove it so I can show you exactly how it works and how it attaches to the telescope. So first of all, I'm going to put back in the standard 20mm eyepiece. Nothing unusual here, it's the one that comes with the telescope. Very good quality eyepiece, a huge lens to see there so you get good visibility. Fits nice and easy to use. And that's the standard 20mm one that came with the telescope. But instead of a 20mm magnification, we can make this one 5 times more powerful using this 5x Barlow. Now, to use powerful Barlows like this, you do need a big telescope. Now, you can get 2x and 3x, but this is a 5x, so it's a very powerful Barlow, and it will take the 20mm eyepiece down to a 4mm, or to equivalent to a 4mm. So you fit the Barlow first, and then inside the Barlow you put the eyepiece that you wish to magnify. It secures in the normal way, and you just use it as you would any other eyepiece. I'll remove it now so you can see it again, and it just secures inside the Barlow, nice and straightforward, but a 5x magnification to the range of the eyepiece that you're using. Now I'll just remove the Barlow lens and replace the 20mm eyepiece, and we're back to standard specification. So a quick tip here, these telescopes are not always the most portable. They are quite heavy, but if you look down here you've got these weights. Now by turning those retaining bolts, these can be easily removed, and then you can move the telescope into position and take the weights separately. This makes it far more manoeuvrable and easier to get where you want the telescope to be. We're going to cover today the Starfinder. I think it's important that we look at this piece of equipment, how it works and how it interacts with the telescope. Ultimately you'll need to calibrate this to the actual lens of the telescope so that you can point at a star using the red dot, and then you can find it when you look through the viewfinder. In order to calibrate the Starfinder, I've got the telescope at a lower level now, so I've lowered the tripod down to a more convenient level so that I can go across to the field there and I can focus on something terrestrial. So if we zoom out, you'll see in the distance a road sign. That road sign is around about 1 kilometre away, and I need something quite far away because I'm going to be aligning the Starfinder with the lens of the telescope. So currently they're not aligned, so I can point the Starfinder at something in the sky, but it doesn't necessarily mean the lens is going to be pointed at it. And when you're dealing with a vast distance, any small inaccuracy makes it very hard to see or find the star. On the Starfinder there are various adjustments, so you've got a dial here and you've got a dial under here as well. You've also got the on-off switch here. We're going to be adjusting these dials to get it calibrated with the telescope. So I can see clearly what's happening through the eyepiece. I'm going to use this really clever camera mount. It allows me to attach the phone to the telescope eyepiece, and it with adjustments, it allows you to get the cameras of your phone exactly in the right place. So not only can you see on your phone what's happening in the eyepiece, you can also record images and stills and videos. So here we have the lens adapter. A little tip for you if you're going to use this is to zoom in a bit on your camera, because that gives you a better image clarity. But it also allows you to focus in and get rid of any bright light. If you zoom out, for example, you do get a bit of light blur. So you zoom in a bit and it tends to give the camera a chance to focus. Just fixes onto the camera like this, onto the lens, and I'll take this off a bit later on and show you it in a bit more depth. As you can imagine, the lens of the camera goes on the lens of the eyepiece. So now we can use the slow motion controllers to move the camera up and down. We're really looking for the other road sign. Excuse the vibration now, try and keep it steady. So we're comfortable now that we have our telescope pointing directly at the terrestrial road sign. It's exactly in the middle of the eyepiece, perfectly aligned. So we now need to adjust the star pointer so that the red dot through the star pointer also points directly at the road sign, and that's how we calibrate them both together. So remember, the front one you turn will adjust the left and right position of the red dot, and the back one will do the up and down elevation of the red dot. Looking through the star finder, you want to get the red dot perfectly aligned on the terrestrial item you're using to calibrate and lock the star finder to the telescope. Okay, so now we've definitely got the telescope lined up with the road sign far in the distance. We now need to get the star pointer lined up as well. So we'll turn it on, put it on the full power, which is by turning that to the furthest it will go. That'll give us the brightest light, and I'm hoping we can see the light on this camera. Now you can just see the dot there, and you can see it's a little bit the dot is a little bit to the left. So we just need some minor adjustments to move it across to the right. So I'm going to adjust it now a little bit. Now, apologies for the difficult footage here. It's hard to keep the camera in focus and turn the dial and hold the phone, and it is very difficult to show you, but I'm trying to let you see just how intricate and how these controls move the red dot across the screen. I've gone a bit too far there, so I'll need to turn it back a bit, and I'm trying to get it on that sign in the distance there. And once it's on the sign, because the telescope is still aligned on the sign, we've not moved the telescope at all. So once we've adjusted this star pointer to be exactly on the sign as it seems to be now, we then know that when we point at something in the sky, the telescope will also point at that item perfectly, making it so much easier to find things in the sky at night. So when you've calibrated it, you should find you'll have the same image on your viewfinder there, perfectly aligned on your telescope, and then when you go over and look through your star finder, you'll see the red dot should be also pointing at exactly the same image. So here we have the red dot on the road sign. And when I built it before, I had the slow motion controller set the wrong way. I had it on this side of the telescope. I've since spun the whole telescope around and reattached the bracket, because that goes at the back of the telescope and that goes at the side, and it does make it a lot easier to handle and a lot more accessible when you're searching for the planets and the stars. As you can see, very subtle movements from this and this one. Now when that was there, it was quite awkward and quite difficult to get hold of. So not only does it look better, it's easier to use in this configuration. Another quick tip for you here. So if we look round to the back of the telescope, you'll see on the very rear here, you'll see these three screws protruding there, there, and there. Now these are the mirror calibration screws. They adjust the angle of the mirror inside the telescope. These are factory set. You do not need to adjust these, so just leave them as they are and don't be tempted to screw them in unless of course you have a problem with your mirror. What I also wanted to show you was the different sizes of the telescope, because obviously the tripod can be adjusted, and we've got it on quite a low setting here, as you can see, and I'm going to give you an idea of the height of the telescope so that you can get a bit of a gauge as to what setting works best for you. Using the tripod in this configuration, you're looking at about 120 centimeters, 1.2 meters, and that's around about 47 inches high to the Starfinder. So in this configuration we have the tripod fully extended, making this telescope a far more formidable looking piece of equipment. Now up to the Starfinder there, we're looking at around about 67 inches, which is around about 170 centimeters high. Certainly gives you the adaptability and the adjustments for different height users and for different applications in different areas where you would be using the telescope. One thing's for sure, the tripod that comes with it, very big, very sturdy, and certainly can take the weight of this telescope. Another quick tip for you here. We're going to look at the standard eyepiece. It's a 1.25 standard eyepiece, and you can adjust the eyepiece inside the eyepiece holder. Now you'll find that's actually got some benefits depending on what lens you're using with the telescope. So when you're using the focus dial here to adjust the focus of the lens, you have so much tolerance within the movement you can get from it. So by just adjusting the eyepiece inside the holder, you give yourself more scope and more maneuverability. So you will find for some eyepieces and some lenses, it's worth just changing the position of that inside the holder there to give you more throw when you're using the adjustments on the telescope. So we've got some footage from the actual telescope here, obviously of the moon. Now this is using the 20mm eyepiece that comes with the telescope. It's the least powerful of all the eyepieces I've got. So the moon is, obviously you can see the full moon more or less in the eyepiece. It's not zooming in that far, but you still get quite a bit of detail and you get quite a bit of clarity while looking at the moon. Now bearing in mind the moon is some 384,000 kilometers away, it's quite amazing that we can see it and get so much detail from these small telescopes. We'll change in a moment to a different eyepiece and we'll go in for a bit more of a zoom so you can see closer what this telescope's capable of. I'll also show you some footage with a Barlow lens further towards the end, so you get to see the magnification and how a Barlow lens affects the view. This is a real simple one, so I'm going to do it anyway. Apologies for how basic this tip is, but when you use your telescope you remove the lens cap or dust cover. Now it's important to remember to always put it back on after use, because if you don't you'll get dust and all sorts of things inside there. Also, you don't want the sun shining in there and damaging your mirror, so remember to replace the lens cap. So here is now using a different lens. Again, apologies, the footage isn't the best, but it gives you an idea of what you will see. Now this is one of the more powerful lenses I've got, a 4mm lens, and now it zoomed in that far that I can't get the whole of the moon in shot because it just won't fit in the eyepiece. It's good though to see details and textures on the surface. Always interesting to get different depths of view when looking at the moon, and you never know what you're going to see. You know, people find all kinds of anomalies and moving objects on the moon. Always exciting to look at it. Always makes the hairs on the back of my neck stand up when I look at the moon. So now we're using a different lens, and this is with the Barlow lens as well. So now we're using the 10mm lens, which is obviously quite a powerful one anyway, and we've got the 3x Barlow, so there's no chance now of seeing the full moon in one shot. We're going to see a segment at a time. Very interesting to see the craters a bit closer and more detail on the moon. The moon temperature ranges actually from minus 173 degrees when it's in darkness to 127 degrees centigrade when it's got the sun on it, so quite a massive difference between the temperature ranges there. Again, apologies, I know the images are a bit shaky. I hadn't practiced too well with the mount and the camera adapter, so they're not the best. I will get some more footage for future videos. And finally now, this is another combination, again using the Barlow lens, and it's using the 3x Barlow lens. I do have a 5 as well. Now this is with the 20mm. So we've not zoomed in quite as far as we have with the 10mm, but you still get to see the craters and the shapes on the moon. So apologies, there's not a great deal of footage for you at the moment. We've not really had the weather, but I will get some more for future videos. I'd like to get some planets, I'd like to be able to show you Mars, maybe even the rings around Saturn, so I will endeavour to get more footage for you in future video releases. Thank you very much for watching this one. Just got some more information for you on the lens phone or camera adapter. This allows you to connect your phone to the eyepiece of your telescope. Now the good thing with this is it allows you to get some really good images, some stills, even video footage of the things you're seeing through your telescope. Now it's fully adjustable and it fits on almost any telescope. We're running with a 1.25 eyepiece, and this bit here adjusts to clamp on the eyepiece, just in there, and this part here will adapt and adjust for many different phone sizes, makes and models. So just check the specifications before you order to make sure it will work for your phone. But it looks quite complicated, but I can assure you it's a really simple thing to get to grips with, and once you start playing about with it and putting it on your telescope, you'll soon see just how easy it is and how beneficial it is to capture those images and the video footage of what you're looking at.